start the open discussion. I hope, well, this last video shows a bit of the work we are doing here at EPFL, and one of the motivations for this workshop is to have different perspectives from the technical point of view to the ethical, and then to the post-analysis of safety when you operate robots around crowds. And then there's, of course, a lot of open discussion and open questions in each topic. So I could ask Tom also, and Pericle, if you are still here, if you have any questions, and for the speakers. We have indeed one question to me. In a real environment, how do you perceive the impacted human body part? That is a very good question, and that's the work we're trying to do with 3D LiDAR is one option, and then cameras. But in reality, what we are expecting is to have the robot to be covered in the specific area with force sensing, knowing that this force sensing is placed at the height or at the possible likeness of hitting specific body parts, so that we can set the threshold for each force control at different sensors based on where it is located and what we show in simulation. Like if you are hitting in the arms, then the sensor that is placed on that height should be aware that it's going to probably hit the human arm. Or if you're hitting the feet, then that force sensor should be aware of that and work with these thresholds. We have one more interesting question for the black box issue, and a few minutes of recording would be sufficient. That's an answer. For the practical issue, video data, tactile data take very large amount of space recording and will have to be limited in time, like to only a few hours realistically. Do you have some initial thoughts into practical implementations for these black box? I think this goes to Carl. Yeah. Oh, I'm sorry. Are you muted for some reasons? I think it's the system automatically mutes everyone. I will unmute everyone again. Go ahead. You can.
Perfect. I'm unmuted. Sorry. Yeah, no, that absolutely. That's the data requirements would be huge if it was a high fidelity, multiple hours of recording. I think that one of the proposals, and partly this is part of the question for the project is what level of data for how long is actually needed to support an in-depth accident investigation, and that's likely to be very different for different domains of sort of robotic system. So the event recorders in vehicles tend to only record a few minutes as they currently stand in cars on the roads. The same with cockpit flight voice, the cockpit voice recorders. There's just a continuous loop which overwrites after a certain number of minutes or hours, depending on the requirements. So yeah, it's precisely those questions which we're hoping to understand. Actually, from a practical perspective, if you try and conduct an investigation on a simulated scenario, what data do you need? How far back do you need to go, and what sort of fidelity and precision is needed from the different sensors?
Yeah, that's indeed very good. Still open question to answer. And in regards to that, we have another question, and I also was wondering that ethically for the black box, it's interesting, but how it might conjure up the connotations of the black box itself, passing some sort of ethical judgment on the parties involved, and what kind of implications would it have for GDPR and the privacy?
Yeah, that's a great question, and it's I guess we can look at other sectors, and there's very strict requirements about what the data that's collected by black boxes can actually be used for. So it's very legally protected. It can only be collected and used for the purposes of safety improvement, and accident investigation reports generally aren't admissible in court cases, for example. So there's very strong sort of legal firewalls between the activities of safety investigation and the data that's collected for safety investigation. There's EU legislation which protects the safety data that's collected within aviation. So yeah, there's some big questions around obviously robots operating in a variety of different domains. What sort of protections might be needed both to give manufacturers comfort that they can install these things and they're not opening themselves up to you know a machine that produces huge numbers of liability claims versus the comfort of users that they're not being continually tracked and going to be held liable for having done something wrong and have the finger pointed at them. So yeah, big very big questions.
Ben, you had a question. Could you ask it?
Sure, yeah. So in the chat, I was kind of curious when we talk about black boxes, like at least my experience or what I know about them is that they also record like trained users, the pilots, they sort of know this is happening. Whereas if we think about an end user, they might not be aware or trained in a way to say things that would make investigations go better. And I think this kind of ties in maybe to some of the ethics and responsibility from that talk, where we think about how do you design the experience of being in an autonomous thing such that it helps a black box. And that was kind of my thought question.
Yeah, that's great. That's right. Yeah, there's certainly as you say, there's the side of things. Can there be a way of I suppose supporting or reassuring people that they're not being recorded just to be found fault with, but on the flip side, I suppose, as you say, there's sort of these professional groups that tend to be subject to black data, cockpit voice recordings. They're aware of it. They see the benefits of accident investigations because it's improving the system that they're working within. So yeah, again, there would need to be, I think, quite a broad public debate and participation in understanding actually what is appropriate to collect in terms of data, how should it be used, who should be able to access it, and all of those sorts of questions. And ultimately, these sorts of things should be for the benefit of the public, and increasing public safety. That's the ultimate purpose. Yeah.
I have one question. Perhaps Professor Kanda, that has experience doing a lot of recordings with actual robots in the malls and in different places. Do you have any thoughts into what kind of data you were allowed to record? For example, you show us videos of children interacting with the robots. Do you have any thoughts or any feedback that you received, for example, when applying to ethical approvals to these kind of things?
Yeah, I mean, still we are in research, and I mean, even within research, we put signboard and I mean, try to make it open that we are recording. So yeah, I mean, this kind of black box type things, perhaps it's very different. I mean, if there is more and more benefit on specific purpose, it might be allowed. But I mean, in general, for us, I feel it's very difficult to record in such data.
And if we were allowed, for example, ethically, let's say we are allowed, what data do you think is actually most useful when you were to record an accident, for example, with children interacting with the robots?
Yeah, I mean, actually, we are recording data in some sense. I mean, for our research purpose, in that sense, of course, video is most useful. But I mean, and particularly it's because in our case, we are interested in human behavior. It's not robot fault. It's more like, I'm not fault, but I mean, human specific behavior. So that's why video was useful. But I mean, for our, I mean, development purpose, often we record all details of the robot, I mean, decision process. So I think depending on purpose, it's very different.
Yep, that is indeed. Tom, you had a question, if you could. Oh, can't hear you, but you are unmute. Ooh, you are lost in the background. Can you try again? No, we can't hear you. Okay, Henry, you also had some comments. Perhaps you can move to Henry if you have a. No. Okay, so perhaps I can ask Tom a question. So Tom asked if we embed the sort of social awareness behavior we have heard about today into robots, could that actually create further mismatch in the general public's mental model of the real capabilities of the robot? How can we help public to understand the inevitable limitations of our robots? Any thoughts? That is indeed a very good question. And it always is a big mismatch between what the real public expects robots to be capable to do and what they are actually doing. If anyone has a specific thought into, perhaps Ren, you can have some comment into the, like, how can we really raise awareness of what the robot is really capable to do? Or it's more like, what is the social value that we are giving to these robots? And everyone should understand what they are doing. But there are many open questions there.
In our research, we always make it clear that if somebody is having an emergency in health, then they need to call 111, or that the robot is not being monitored 24 hours a day. And so we always make it clear that they shouldn't depend on the robot if they've got a real problem. The other thing we try and do is make the robot itself explain to the person what its capabilities are. And, you know, say, it says, you know, I'm only a robot, I don't understand everything, that kind of thing.
Yeah, indeed, interacting directly with one. But for instance, in the case of crowds, it becomes a bit more difficult. If you have pedestrians around simply going by and seeing the robot once, they don't want to spend the time, or they don't have the time to understand what the robot is capable to do. So they come with a mindset of what this thing might do. But then
that's true.
That's where we wonder, like, how can we keep this? How can you share this knowledge that this robot here outside is capable and is limited, and people that just is by standards, they also should be aware of this.
Yeah, I think one of the problems as well is science fiction movies showing robots being far more capable than they actually are. So perhaps we need to make more public what the actual capabilities are, because you always read in the media as well, like journalists talking about robots taking people's jobs, which is always very annoying.
Yes. Perhaps Ren has something to say about that. Okay, so also we have a question directly for Ren. Ethical considerations are extremely important during technology innovation. Unfortunately, I know several engineers and roboticians who seem to ethics as a roadblock to their research and development work. How can we better engage them in important ethical debates and guide them in seeing ethics as a simply a box thinking exercise? What do you think? We can't hear you. Can you try again?
Okay.
Yes.
Now I'm on, I think, no?
Yes.
Yeah, well, I mean, this is exactly where I come from. If I hate something, then it's this box ticking when it comes to an evaluative form of ethics. You know, I have not so much experience in the fields you have addressed at this conference, but I have some experience with what is called in agriculture precision agriculture. And that precision agriculture comes along with all types of robotics. So you have unmanned tractors, you have drones which can predict the weather within 3 hours locally, can detect soil circumstances, whether you know, you need particular pesticides and so on. So from that perspective, you could see an agricultural system which could soon be robotized, so to such an extent that farms will be unmanned. There will be no human beings on farms anymore. This is very, very imaginable. Now, what's the problem with that? I think the problem as such is, again, where I come from. My main thoughts on responsible innovation is not so much on the individual ethics or whether this drone can cause safety problems or something, or this tractor does something wrong, which is obviously also important. But what I worry more about is how this system then is functioning in our society. And that vision of agriculture, which is robotized, comes along with a centralized data system where, let's say, somebody in the head offices of Detroit can manage farms remotely. But that means that you will have a further commodification of agriculture, which is then further market driven, which means we will have within 10 years actually probably only commodity productions. Now you can also envision a robotized agriculture where the ownership of data remains by the farmers, and where farmers share their data with other farmers in order to optimize their work with similar technologies. I mean, you can design these robots in different ways. You can use them for large scale agriculture, but you can also use them for small scale agriculture. Very well, they are actually not so expensive. So these technologies are very useful actually for small farmers to directly sell their products online, to work together, and actually achieve a better type of agriculture than we have right now. So you have two different types of agricultural systems, if you like, where one is based on a centralized system where robots and their data are centralized by big multinational companies, or you have a decentralized system where data are not owned by the big companies. Now we do have, and this is why I emphasize this public-private partnerships, we have, for instance, at the European level already a sort of code of conduct where we decide in Europe that it's preferable to have the data owned by the farmers. But these legislative decisions are helpful to shape technologies and robotics, in this case, in a certain direction. I think when it comes to public deliberation, the public deliberation is still too much on the level of individual artifacts of products, of what are the safety aspects and so on, although this is all important. But we have not yet a good public deliberation, how we want to shape our agriculture, for example, how we want to move forward with this. And I think this is where we need to place robotics in this broader context. It's not the single drone with the issue or the unmanned tractor. It's the interrelation of all these technologies, which will lead to a robotized agriculture one way or another. We can shape it, and this shaping dimension, this what I call an ethics of construction, not an ethics of evaluation of something, but how can we design our systems? How can we even design our agricultural systems? And we are capable of doing that. But we leave it now to global market forces, and that means predetermined outcomes. And in my vision, actually, predetermined negative outcomes.
Indeed, we have to evaluate a lot, like what's the weight of robotics and the benefits and how everything is interconnected to solve these ethical questions and really have focus in this sense. In the sense of Crowdbots and what we are doing, we are trying to start the technology from that point. There are robots that are going outside and they're going into crowds, small crowds probably at the moment, but still they are starting to be out there. That's why we want to evaluate what are the risks of that and what we are doing. To that, we have a question from Professor Kanda, and it says, I'm curious about the project. Oh, you can.
Yeah, yeah. I mean, from your presentation, I believe that you assume robot expect, collisions. And I think we typically try to avoid situation where robot could invite collisions. So I'm curious.
Yes, I can show you a quick slide here. I hope you can see it. So in reality, of course, we don't want collisions, but as I said, collisions are unavoidable. It doesn't matter if we have these collisions avoidance systems. If the pedestrian comes and wants to hit the robot, they will, as you have experience with it.
Yeah, but at some density, it can to be really, difficult to avoid. If it's low density, of course, some, let's say, careless people might collide, but it's, I think, very different from, having such collision with careless people, and the situation where robot might by itself hit into someone.
Yes, but in our case, we consider, for example, crowds that are unavoidable, like if you are escaping of a mall in an emergency situation. In this case, a crowd will be created within minutes, and a robot will be there, not simply because it wanted to be in a crowd, but it happened to be in a crowd. So in those cases, then what is the best control that we could put? What is the best action? The robot should simply go away and try to avoid the crowd or stop. And this kind of analysis is what we are doing. For example, in this paper that we worked on, we try to assess the different risks from hitting a pedestrian, different type of pedestrians, perspective from the different people around, and what can we do? And exactly that's the question, like when the benefit will outweigh the risk. But the measurement of risk is still very open. So that's what we are trying to address in this research at the moment. And I don't particularly say that I have already, like this is an application where the robotic compliant control will be useful. But for instance, having the a wheelchair with a compliant control, what might help the user of the wheelchair as well as the bystanders. So these are simple examples, but still, this is indeed very, very open. Perhaps Tom, you can have some, if you can talk now, Tom, I don't know. Other ideas into the Crowdbot application. Let's see, Tom is here, yeah. Still, I hope, well, in the worst scenario, when we actually hit a pedestrian, we can have some level of compliance, or at least avoid the issue of having a freezing robot, because we think that having a robot freezing in the middle of a crowd will be the worst scenario, because then you're likely that everyone's going to hit with the robot and you're going to cause a worse injuries and worse accidents to everyone around. So that's why the focus of the Crowdbot project is to trying to mix all these technologies of reactive navigation when you collide, planning before you collide, planning in the high level so you actually never get into a crowd that dense. But we kind of want to build into all these layers, assuming that at the end, this will happen at some point. Maybe not in 20, 50 years, but it will happen. I think we have some, no microphone yet for Tom. Okay, is there any other questions we want to address directly from all the participants? I think I have unmute you all, so you should be able to just speak if you want to. From my side, I had one more question perhaps for Professor Broadbent, if she's still with us. I think so. So it was about, well, you talked about the level of safety and the perception of safety and how you put these robots in the research concept. But do you see, for example, in the facilities, in the lab facilities, that the risk or the perception of that these robots are useful and safe, is it enough at the moment to really go for them? What was your experience with this kind of implementing this into a real lab and having the robot moving around?
Yeah, they seem to be, the perception was that they were safe enough. I guess there were other reasons why they weren't kind of implemented on a permanent basis.
Mm. And do you have some regulations that you have to overcome if you were to really implement these, or because it's a private lab, for example, they could simply use it? Or
It was a private lab, so they could use it. I mean, they already have a lot of robots that, you know, they use in the blood testing business. They, you know, like shaking the tubes, moving them along the sort of in the facility, but this was just moving them from one bench to another. So there might be some safety regulations that they would need to pass. For example, they talked about spilling. If there was a spill inside the robot of the blood, there needed to be an alarm and that kind of thing.
Okay, that's interesting. And in the other scenario that you tested, for example, with the elderly home, the elderly village, I think it was, do you think it's there is a outweighting of the, well, in that case, I guess it was a more small robot, but how can you weight the safety of these robots, safety regulations, or what kind of procedures do you think should be taken into account for implementing these robots?
Well, I mean, I think it's probably the, you know, the idea of the kind of black box always recording is a good idea to make sure that there is, if there is an accident, then we know what preceded that. But yeah, again, sort of the rooms of the residents were away from the corridor where the robot was moving. It was more moving, it was quite a wide corridor, and it was moving from the kitchen to the dining room past sort of common areas rather than the rooms. So it seemed to work rather well. So I think perhaps the design of the facility has to be an important consideration. So some of the rest times, you know, they have very narrow corridors, they're very old, they've got steps. They're not suitable for robots, but some of the more modern homes, they are suitable. So I think it's, yeah, the building design is important.
Yes, I think, yeah, we should take everything into account. Where are we placing the robots? There's one more question for you. Do you think we could take some of the findings from the dialogues with robots and translate this into improving the trust in a mobile service robot?
Possibly, yeah. I mean, if they are robots that actually talk to you, then, and they're sort of vaguely human-like, then I think that it might work. If they're not human-like and they don't talk to you, you might need some more research to see how this works.
Yes, indeed. So I think those are the questions we have at the moment. And I think,
yeah, the non-verbal gestures and cues, yeah, they're very important, I think. And I think different cultures as well could interpret different gestures differently. Like, you know, in Asian cultures, you have more kind of bowing than you do in non-Asian cultures. But some of the gestures, I think, are similar between cultures.
yeah, but I guess, yeah, some of, for example, what Professor Kanda showed of the robot and the way approaching, I think that's a very Japanese way to approach a person, and very politely. Whereas in here, in Europe or America, it might not be the same. What do you think, Professor? Yes. Does it hold the approaching a pedestrian and the robot doing its hard behavior in the front or laterally, as you show?
I think probably laterally, as was shown, is better. You know, but I guess New Zealand is quite an unpopulated society. So we used to more distance between people. We don't like crowded places.
Okay. Thank you very much for all your input. There is one more question. Do you think you could take some of your findings from dialogues? I know that was the last question, sorry. And also for non-verbal gesture cues, personification of non-verbal. What kind of personification can you do?
Yeah, I think that's true. Like with you can express your personality through your movement. Like if you're fast, you've got a fast tempo. It indicates you've got more energy than if you're kind of moving slowly in a repetitive kind of dance style.
Yeah, I guess we can try to embed that into the robots. I wonder how easy is that for a normal pedestrian to read when they are just walking by.
It's interesting because there is research showing that depressed people walk in a different way to healthy people.
Yeah, we can show that in a robot perhaps. So I think we are getting to the end. I really thank you all for being here and presenting all your work. And we will keep this recording and we'll upload it to our website, the Crowdbot website and the workshop website. I hope you all are okay with that. I think I received some replies already, that was fine. Thank you very much for attending. There is no real conclusion here because all of our questions are very open-ended, but it was very interesting to see all the work you are doing, all the work we are doing, and from the technical perspective to the ethics and the involvements in safety and how can we analyze it. Everything needs to be taken into account. And it was a very interesting workshop. I hope you have enjoyed, and thank you very much again for coming.